today's webinar. Today, Micheal Firlotte will present on the topic of water loss and water aging. Water distribution is often overlooked by water suppliers. Water distribution and distribution integrity is an important component in the safe water delivery. In this webinar, Micheal will be presenting on topics related to water distribution, water aging and distribution, and water loss. He will talk about factors that lead to water aging in distribution mains, implications of water loss in the water main, how to address water aging through the use of flushing plans and other strategies, how to identify and address water loss. Micheal Firlotte began his career as a water treatment plant operator with the City of Kamloops in British Columbia. Over the next 12 years, he progressed from operator, chief operator, distribution supervisor, and finally, utility services manager. He left City of Kamloops in 2016, worked as an acting director of public works and regional utilities for the City of Abbotsford from 2016 to 2018. For the last 2.5 years, Micheal has made the City of Penticton home and is currently the water quality supervisor. He has served on the board of the Environmental Operator Certification Program, serving a term as chairman from 2019 to 2020. He's been involved with operator education since 2005. He's been an instructor, developed curriculum, delivered training access for across BC, Alberta, and the Yukon for a variety of subjects, including water treatment, water quality, and system liability. Micheal currently lives in Penticton and enjoys the beaches, skiing, and long distance cycling. Penticton's a beautiful spot. So I'm going to hand this presentation over to Micheal now, and he will start. Where are you here?
All right, good morning, everybody. Natasha, can I see my screen?
Yeah, it looks great for me. Thanks.
Perfect. Well, welcome everybody to this webinar on water loss and water age. I'm honored to be speaking on this topic. It's a topic that you don't hear too much about, but it definitely all affects what we do. Just some updates to my bio, actually. So I am currently in the Yukon. I'm with the City of Whitehorse as their water and waste services manager. So a little bit of a change for me, and it was a balmy 2 degrees this morning. So for those of you on the call this morning that thinks it's cold in your neck of the woods, it's pretty chilly up here. Like Natasha said, there's some topics I want to talk about in regards to both water loss and water aging. Water loss, what is it? Let's talk a little bit about that. I want to talk about non-revenue water, leak management, what this really costs us in the end, and some of the mitigation points, which could be a water audit, for example, water main breaks, and looking at how do we categorize those. Water theft is always a big one. And I threw in a little bit of a case study in regards to Halifax. And Halifax Water has a fantastic way to look at how water loss affects their community. In regards to the water aging piece, I've kind of put that in among these topics, so as they come up, we will chat a little bit about them as well. So let's start. Introduction. So we all know safe drinking water, it plays a crucial role. It promotes everything in our communities, right? It's the health, food production, green grass, manufacturing. So really all aspects of our life, water touches. And over the years, we focus really hard on getting the water to the customer, making sure it's safe to drink. And I think, most of us in the industry today have done an outstanding job of this, but we can do a better job. Now we got to look at some of the revenue and how do we actually do business. So we have challenges. We all do. And every municipality out there does, in order for us to do business. We do such a fantastic job. So now let's look at how we can be efficient in supplying and making sure that we're making revenue so that we can continue to serve our customers. Again, one big thing, and you guys have all probably seen this in the last few years, is the whole topic of capital reinvestment. All our pipes are getting old. So it's really important now that we're making a move to make sure that we're upgrading the mains that are in trouble. All our infrastructure is aging, and making sure that we're putting better infrastructure in the ground. So you know what? Abundant resources, it was always available for us. We're seeing some stuff happen now, right? Climate change. And we see it. We've seen it with the droughts in the Okanagan, the weird rainstorms in the Lower Mainland there. Look at the Merritt and those places. Huge changes in our weather patterns and all these environmental stresses that are out there. So for a lot of the water utilities that are out there, the amount of water they have today is likely the greatest volume they'll ever have. And so let's make sure that we're treating this with utmost care. So we have to make sure we're accountable in the practice of delivering the water and highly efficient in the operations. So here's what we're seeing, right? Droughts and weird weather patterns. So we just got to make sure that we're on it. So let's talk a little bit about water age, and it's exactly what the title means. How long is the water in our system? We do a good job bringing this water in. We treat it in various different ways, whether it's just basic chlorination, disinfection, or to a full treatment process. That water leaves our facilities, goes out into our pipe network, into reservoirs, and makes it to our house. That takes time. So that time that it takes for the water to travel from our treatment facility to our customers is influenced by the distribution, the flows, how long our pipes are, how long it sits in those reservoirs. So we have to really start thinking about this, right? What's a reasonable time to have water sitting in our system? And then we have to look at, okay, if we don't have, the water's not leaving that reservoir in a given amount of time, what are we going to do about it? And looking at, too, if you're living in a municipality that has different requirements due to, say, agriculture, or, people use a lot more water in the summer for washing cars and watering grass and stuff, that makes a huge difference. So adjustments are going to have to be made to the operation of the system in order to keep that water age correct. When we look at it, we're going to do kind of assessment. It always is good to figure out what is the oldest area of water in our system. We all have dead ends and maybe areas that maybe don't have big usage, or larger facilities that don't have a lot of usage. The age of the water affects the chlorine levels. So, and when there's chlorine decay, we all know that there's potential for biological growth. And so we always have to be aware of that. Areas of low demand create low velocity, and that also in turn creates increased water age. For those of you out there that use different technologies like altitude valves or something to fill reservoirs, you always have to make sure that the turnover in these reservoirs are correct, or else you end up with some dead spots. Mixing and reservoir management are top things that you need to look at to make sure our water age. We all know some of these older reservoirs, one pipe in and one pipe out, and you get these these cells in there that don't move around. So water age is really a simple surrogate for evaluating some of the water quality issues in your distribution system. Take a look at what you have coming in for complaints. Maybe that's one particular area. Maybe it's more widespread. The distribution system tanks are definitely a major contributor, and some of the older tanks lack the baffling and and the one pipe in, one pipe or another pipe coming out. You know, I think all the new ones are coming on are much better designed. Hydraulic modeling is in your system is really valuable tool for examining the water age. And so this modeling can identify the problem areas and look at the solutions that could be done to rectify that. Let's focus now a little bit on the water loss side of it. I'm really curious about water loss because I think there's a bunch of stuff out here that we don't even realize. And when I was writing this particular form, I was like, oh wow, I didn't even think of that. So let's go through some of these things. So what is water loss? It's the efforts of a water utility to provide accountability in their operations, right? We want to audit our water supplies. You know, typically we do a really good job of bringing water in, knowing how much we brought in and knowing how much goes out the door. A lot of us have the larger flow meters, and so we know exactly what's coming through those stations. But once it leaves our facilities, do we really know how much actually gets to our customers? You don't know what you got till it's gone. And I know that's a cheesy 80s song, but it's really true here. How do you know how much you're really losing? So it's really important now to look further into what happens when the water leaves our facility. Utilities, big and small, they incur losses, and it's typically pipeline leakage and apparent losses. And these are the losses we don't even think about, right? Like when you see a water break or a leak, that's really easy to get your head around. We'll talk something called apparent losses, and that's really going to be something to talk about here. So this could be a number of things. The biggest one is that consumption is not properly measured or it's not properly billed. And really, if you look at folks out there who do not have a metering program or do not meter their water, that's a huge one. We're estimating or we assume how much water is being consumed by our consumers. You know, no water system's perfect. Everybody has losses, and that's going to vary from system to system, and that can have something to do with definitely how much water is going through that system. How old is that system? How well was it built? What type of pipe is in there? Unfortunately, most water utilities do not regularly audit or account their supplies to quantify the losses that go out the door. And again, it's fine to have losses, but there's a cost to this. And this cost goes to our customers. You know, we talked about that first one, right? The losses in utilities include the physical escape of water, you know, from the pressurized piping system. And that's leakage. And that's real losses. But again, the other side of the coin, the inaccurate metering of the customer's consumption, theft is a big one, right? Maybe issues in the billing itself. One big one I always shook my head at is that, you know, we pay for water and new subdivisions get built and we put a reservoir on the hill. And none of the houses are built yet. And as one or two houses come online, that reservoir is full of water. And now, you know, because we talked earlier, the importance of water age, that water times out. And so what happens, your crews go out and you use a fire hydrant and you basically flush the water that's aged out of that reservoir and put fresh water in. And again, that water leaves. It didn't go through a water meter. It did not go to a customer. It was lost. And again, because that was lost, we didn't get revenue for that. And we don't get revenue, then basically everything costs more and for our customers. Another one is the older, poorly constructed pipelines that are out there, right? And we all have them, right? Stuff that was put in the 70s and 80s, and they're starting to leak a little bit. Maybe they didn't have the corrosion protection they should have. For those folks who use ductile iron pipes, right? You see what happens. Valves and, you know, things of that nature, they leak. Maybe there's a problem with the bonnet. Maybe there's some damage to them. And these all form contributing factors to the leakage. One effect of the water leakage, beside the loss of water resources, is reduced pressure. So you have a subdivision maybe now that maybe the pressure isn't quite where it should be, right? And so as a utility, maybe you tweak the pressure reducing valve or pump a little harder to increase that. And that's energy consumption. And that puts strain on other portions of the water supply system. So just kind of a rough note here. I mean, let's aim for 10%. Like, if I have 10% water loss, I think we're doing pretty good. But as you're starting to creep to 20 to 30%, we really need to think about what's happening. Think about 30%. If you have a facility that's putting out even 1 million liters a day, think about what 20% losses is, and times that by 365 days. That's a significant amount of water out the door. And if you look at your bylaws, or if you're charging for water, that's a loss of money, because that water did not end up at a customer and was not purchased. Let's talk a little bit about non-revenue water. And that's something that's, we don't even think of. This is the real plus apparent losses. And it along with the unbilled authorized consumption. And we'll talk about what that means. This represents that water that's used, say, stuff like firefighting or hydrant flushing. And, most of the people on the call and working in distribution have flushed hydrants, right? So you open up that hydrant and water escapes. In a major structure fire, there could be up to 3 hydrants pumping water. And that's all water that's authorized consumption, because, that's the whole object of a fire hydrant. But this water does not go through a water meter, and it's not captured. Non-revenue water compromises the volume utilities lose from their water supply infrastructure. So we still have to treat this water. We still have to get it from the environment. We have to add the chemicals to it. We have to make sure it's safe. So we still have to go through all the motions. It's just that we're not recovering the revenue. It lost revenue from a portion of this supply that reaches the customer and not billed. So like I said, that's the big one. We're flushing that hydrant as part of maintenance. Imagine if you have a medium-sized community, how many fire hydrants do you have? How long do you run that hydrant for? If you added up the amount of liters that come out of these hydrants for maintenance purposes, that's non-revenue water. The other one is firefighting. In a major structure fire, and even a small one, that hydrant's open, they're using water. And that water, again, is non-revenue water. Uncontrolled non-revenue water results in numerous impacts negatively to your utility and for the community. What I'm concerned about is where you have limited water resources. And I'll take in the Okanagan area last year, we had a significant drought. And for those who use snowmelt as a means to fill your reservoir, those levels became very low, as well as a lot of the groundwater sources in the areas had very, very low water levels. And again, when we have leakage to the point of in the 20% range, it's a waste of precious water and energy when it comes to this water produced. And it's not being delivered to the customer. We do usually a really good job, right? We're going to go drought level, 2, and we're going to conserve so much water, yet the leakage is there. So we have to look at that as a factor as well. Again, if we do have these constrained water resources, and we're not filling reservoirs like we used to, and there's so much leakage, limits could then be placed on new commercial or residential development. And it does put a hold or slows down any sort of development because of shortages in the water supply. Again, a big one's drought, guys. And we saw this, like I said, in the Okanagan. That was a big eye opener. We had a couple of years of drought. This year, I think we had a much better year, but still, these weird weather events due to climate change. We have to kind of look at this, and water resources are going to be very precious in the future. And we need to do all we can to make sure that we're mitigating any sort of losses. So let's look at leak management. So this is probably a good way to start to mitigate this anyway, and start the discussion at least. So damaging water leaks and large water breaks are visible. And I like those. We've all seen them, right? We walk down the street, there's water pouring out at the side of the road, or you see construction crews out there repairing something. We can see these things. We know that there's a break. They're very costly, but we can see them. What I really kind of wonder is the ones you can't see. How many do you think are out there that we can't see? It's leaking just enough, or the soils are a type, maybe it's gravelly or sandy, and the water's going away, or it's coming out in a different spot that we can't see. So keep that in mind. These can be very costly. It compromises the confidence that communities have. So if you have a stretch of line that has a number of different breaks on it, most communities have those problem areas, right? We've got another break on this and another break on that. You have to kind of take a look at that. Fortunately, now there's been a lot done in regards to leak management practices, and there's some different technologies that can be used to recover treated drinking water. That's been going to waste. As you see here, you got a blue box and a red box in the photo here. And so what you can do is actually drop these little listening devices on top of the valves, and they'll listen. And you've all been inside your house, and you can, if your water's running, you get that sound, right? That sound. And that's what these things are listening to. These go a step farther. What they'll do is they'll look at the type of pipe, and they can almost estimate exactly between the 2 points where the leak could be. And this is a leak correlator. Other devices that we see out there is all types of listening devices. You can see in this photo here on the left, the lady's got the earphones on, and she's actually checking for that hydrant to see if it's making any noise, right? Most people out in the utility world, they'll have something similar, or they'll be able to listen to valves. We can also put loggers and different listening devices. You can put them onto hydrants and different valves overnight, and you can kind of get an idea if there's potential leakage anywhere. Ground microphones as well, so you're listening. So it's really a game of let's listen and figure out where and if there's leak. Let's not wait till we see it come to the surface. Let's do a whole sweep of our infrastructure to make sure that all the water's staying inside the pipe and it's not running through. Typically what they'll do is they'll go at about 3 in the morning, something like that, when there's very little traffic out there. So it will listen and be able to determine if there's leakages. Sometimes we do hear it, and we'll go back out again just to make sure that maybe somebody was doing their laundry at 3 in the morning, or so we'll do it over a number of days just to make sure data is correct. So apparent losses mean to water utilities that do not realize all the revenue needed to reinvest in the system. So really what that means is that I think I'm getting all the water, but I'm not. And all that water that's leaving, I'm not getting revenue. And that means I don't have the revenue to do the repairs or reinvest in the system and making sure that we're keeping up on the maintenance costs. By minimizing the apparent losses, utilities can bring in additional revenue, which is fantastic, or not lose the revenue that they projected in the first place. And that helps fund the system renewal. And then really, that is the big thing, aging infrastructure. And I said that earlier in the presentation. It's all happening. It's happening to all of us. So we need to be prepared for this. So what's the cost of this? Losses cost money. So let's really look at how much this really does cost. The cost of producing drinking water varies from utility to utility, and that's really depending on what you have for a treatment process. You can have a very simple groundwater well and add chlorination to it. You can have a full-blown water treatment facility. You might be adding different chemicals and using a fair amount of energy to produce the water that you need for your customers. And again, big difference between a smaller system and a system that maybe puts 100 million liters out the door a day. And again, geography. What do you got there for water? Am I pumping it long distance from the source to the treatment facility? In some places too, they have a greater cost for energy than others. Typically, we withdraw water from a source, right? And that's going to be rivers, lakes, or groundwater are usually what we have, or a blending of a number of these. Water is then treated to the regulatory standards and pumped through an underground piping network and finally to your customer. A lot of places too will purchase treated water from neighboring systems. And again, when you're purchasing water, that's a huge cost. And so all this is a cost associated to treating water. We also have to pay our staff. We have to pay the administration. We have to pay the electricians and the millwrights and the contractors that keep this going. Most utilities now include water meters. And I think water meters is a fantastic thing in regards to this. It's really hard to account for losses when you don't know what's going to your customer. So most utilities now are moving towards a water meter based system. And that basically measures the supply of water, records the quantity, and so that I'm billing on what you actually used. And imagine, like in the old way of doing it, you have two houses, very similar size, and one has 4 kids and the other one's just a retired couple, and they get charged the same. And one's using 4 times as much water than the other. So it's really hard for utility to estimate how much water is used and how much revenue is brought in. Unfortunately, all utilities incur some sort of inefficiencies or losses throughout their system, both in supply and because of customer-related functions in the operations. It's a long, twisted way to get water to your home, and there's a lot of spots in there that it can go sideways. The cost impacts, such as quantities of losses, are hidden from utilities and their customers, right? The water rates go up. Yeah, we're adding, 10 cents more per cubic meter onto your bill, and you don't really realize it, but it does happen. The paying customers ultimately bear the financial burden of the utilities inefficiencies, and that's really, we have to do a better job of making sure that we're efficient. In the exercises of setting water rates, that's done by an estimate. We're saying that there's this many people, and based on historical, this is how much they use, and this is how much we should charge in order to pay for the system that's running, be able to do the repairs and maintenance, and also have money for capital reinvestment, replacing some of that aging infrastructure. When all of a sudden we have more and more leakage, that water is not getting collected in our customers' homes, not getting revenue, and that becomes a big issue, and we have to start raising water rates to reflect that. Water utilities set customer rates and charges that are specific to their own cost of doing business. And that's going to be different for no matter where we are. When utility experiences this leakage, especially in its water distribution, the losses drive up the production cost. And basically, we also have to withdraw more water from its sources. And we talked about earlier in the presentation about the climate change. And, if you have a low reservoir to begin with, any sort of efficiency that we can do is greatly appreciated and helps all the communities out there. We'll talk a little bit about the apparent losses now. And this is the inaccurate customer meters or theft or billing issues. Again, it's just as important as the leaky pipes in the ground. It means that there's an error. And I mean, granted, we're not losing physically water, but we're definitely not paying for the water that's either going through the meter or not. So utilities with relatively high water rates, charges suffer a relatively greater impact due to uncaptured revenue. So imagine that, right? The combined annual financial impact of real, which is our physical and apparent losses in the utility operation, this could reach millions of dollars. And think of a place like Metro Vancouver, and if you were losing 20% of the water, they produce or could produce 1.8 billion liters a day. Do a quick think about that in your head. What's 20% of that? That's a huge amount of water and a huge amount of revenue that could be lost daily if things weren't looked at. So one of the things we'll talk about is the AWWA has a water audit. And I think that's really important to talk about. Even if we're not using this particular one, a water utility should track the annual volumes of water they manage. They should measure not only the amount of water supplied to the customer, but also the water lost. So really looking at everything we do when it comes to water audits, we're going to look at what comes in, what came through the treatment process, what actually, and if you're metered, how much actually made it to the customers. We should always track the loss. The other thing we should look at too is in log in our audits, and we'll talk about that in a second, but making sure any major events that have happened, that could be major leaks, major fires, anything that have used a lot of that non-revenue water, we should actually be logging this and trying to figure out an approximate volume each time then that's used. The foundation of a water loss control program is really that annual water audit. Let's really think about how much we've used. It's a systematic examination of records and financial accounts, really, that make sure it's accurate, and making sure that I'm going to charge you guys as a utility owner the correct amount, that we're not losing, that we're not putting out water that we're not capturing. Now, audits are common in the world of finance, right? You get audited all the time. We should be doing this here in our water utilities. We need to look at the records, the data. We need to trace the water from its source through the treatment process into the pipes, into the customer's homes. And we need to figure out, where are we losing water? We'll talk about in the Halifax example in a little bit here, but you can also put meters into zones. So now you can kind of pinpoint potential losses between the zones of water. Maybe that goes into a pump house, or you're looking more at your reservoirs, but definitely looking at how much water is moving around the system and quantifying where that water is. The water audits usually exist in the form of a worksheet or a big spreadsheet or something on your computer, and that's going to details all the water supply. And I think we do a good job of that. Most of you have to put a report out to your health authority in order to make sure that they're aware of how much water you've produced. What we're looking at here is let's just go that one step further and figure out, the correlation between how much left your facility and how much is going to your customer's home. The standard water audit also tracks the cost and calculates a variety of performance indicators. This assesses the efficiency of the water utility. These could be great tools. So you end up with a benchmark that you can use year after year. And if you start to see things degrade further and further, now what you can do is say, hey, City Council, I need funding to replace this water main because we're actually losing this much dollars. And I think it goes a long way when you can start proving things like that. Things make sense. Check out this stat here. This is really interesting. So in 2013, AWWA looked at 246 water utilities, and basically the apparent losses was 29.4 billion gallons. Like, imagine that. That's a ton of water. And that really, when you look at that much water leaving and the rates of those 246 utilities, we were losing $151 million a year. Imagine what you could do with $151 million in your little utilities. That's extra parts, pieces, shovels, pipes. That's all from lost water. So it's really important to think about this. This is not a little thing. This is a huge amount of water. With the development of the AWWA methodology, and that's the one that's most widely used in regards to the water audits, they've been, it's available to every water utility. They need to audit their supply and distribution. The water audit also provides the foundational data to plan a cost-effective strategy to control excessive losses. For those of you getting into the asset management world, it's really now important to figure out the shape of our assets, right? Maybe it's just age of it, but now let's look a little deeper. Maybe age, material type, and with some data we have here, we can kind of look a little bit at a bit more in depth of where our problem areas are, and that will help in our asset management. This will be available in PDF later, and I put a URL at the bottom here for the water audits and loss. These are great books available from the American Waterworks Association, and if your system is interested in doing any sort of water auditing, these are great starts. And they have a website as well that has some directions on how to perform water audits and what the desired incomes could be. Let's talk about water main breaks a little bit. I mean, that's the easiest one to capture. We talked a little bit about this asset management program. This is where this really comes into play in planning a leak management program. And now we're not talking the apparent losses. These are the real physical losses. We should determine the nature of breaks or leaks. What is it? Is it soil type? Was it the type of material that we use and it's causing issues? Maybe it's one type of material that's causing more issues than not. We need to carefully document what's actually happening out there. Why is it leaking? What made it leak? And maybe we can now start targeting this for future. I mean, there's lots of places this could be: water main piping, fire hydrants, the customer's lines. The nature of repairs too, and related information as the damage. Taking a look at the pipe. getting it more assessed. These are all things you should be looking at. It's not just a water break where you go in and you're doing the repair. Let's look at this a little bit more. Hey, we've had 4 major repairs on our ductile iron mains this year. That should be a red flag. Maybe how much ductile iron do we have in our system? Maybe we should look at the age, and maybe they're all starting to get to a point where they're going to warrant a replacement. Other things you should look at too, and we don't even think about this, is system pressure, right? If pressure changes in their system, that should be a really wake-up call to you. Something's changed, and we should really look at that. We need to look also too at the cost to conduct the leak detection work. Maybe we bring in a contractor, or we bring in our own forces to do the leak detection work. We need to look at better managing the excessive pressure and making sure that, you know, we're not, that could be from improper PRD maintenance or something along those lines. And we should also be, you know, working in our capital reinvestment to renew the water piping. You need to look at all this data. And the right combination of repairs should be placed to bring the leakage down. And again, remember, everybody's going to have leakage, and you know, 10% leakage is still pretty good. One of the things I think is part of the asset management, and people are starting to do a really good job on it, but I also try to use a risk and criticality matrix. And that basically looks at, okay, I have a dead end main, I have a ductile iron pipe that's got a small leak on it, but the risk is low and it's not a critical main, it's at a dead end. Versus that same main, maybe it crosses a major highway, maybe it feeds a hospital. There's a lot more risk and criticality in that particular main. So it's applying these risk and criticality factors to your asset management project. So knowing where are the mains in your municipality that's going to cause the most risk, and therefore it's the most critical that we make sure that they're sound. You know, utilities should also review how they do the repairs. You know, Band-Aids are great, but we shouldn't rely on them, right? We all do it. You know, we put the repair clamp on, and this main has 5 repair clamps on it. These are all Band-Aids. And keep in mind, when you put a repair clamp on, that is no different than a Band-Aid. And I know it's hard, but those are the things we need to start tracking so that we are moving towards main replacement, and that, you know, if this is leaking in this particular area, maybe it's leaking in other areas in this nearby vicinity. So we need to make sure that we're looking at our policies and, you know, and how we're repairing these mains. The other one that's kind of scary too is some utilities place responsibility on customers to revert for repairs of these lines. So a lot of leakage can happen between, say, where it comes off the main that's owned by the utility and the meters inside the house, and so that there's leakage there that's not controlled by public interest. It's private. So making sure that you know, there's a mechanism or some sort of inspection so that we're making sure the materials that are used in repairs, especially on the private contractor side, and is done. And also too, when you use private contractors to do the installs of any sort of infrastructure, that it is inspected, it is done to the policy and to the standard that's required for your municipality. Because the last thing you need is more problems, more leakage. You know, finally, water utilities should have that asset management program. You know, if it's not official, you should have something that should tell you, you know, in the next 5 years, what infrastructure needs to be replaced. There should be some sort of system of renewal. or rehabilitation that's at a level that's, correct, not 1% or 2% of the mains. We should actually be working towards a larger percent of capital reinvestment. And again, this isn't cheap. And unfortunately, that's we're all dealing with public money, and that sometimes becomes a very challenge to the water managers out there. Let's switch gears over to theft. And theft happens. A little harder to navigate, but it does happen though. Again, water services are not immune to that occurrence of unauthorized consumption or theft. So some members of every community are willing to tamper with the water meters or water meter equipment. I got called out a number of years ago to a water quality complaint, and the individual had gasoline in his water or oil. So I showed up at his home and I did the sample, and sure enough, it smelled like oil, and it was pretty strong. And so I said, well, can I take a look at where the water comes in? And so he got pretty defensive at it, but I did take a look. Opened up the meter pit at the property line, and he had a garden hose, which are pretty porous for those of you who use the garden hose. He had the garden hose bypassing the water meter under his driveway, hooking into his service into his home. What made matters worse in this case is that he was performing oil changes on his vehicles and dropping the oil into the driveway. So basically that water hose was basically in an aquifer of oil and was getting into his service. Needless to say, we did fine him, but you know what? Don't do it. Don't bypass the meters. I've seen people put tinfoil over them. I've seen people turn them around. The newer meter technologies now can pick up on a lot of this, right? They know when things run backwards. They know if it's not reading. It's really important when you do a metering program to get a meter that can do these things. Water theft's another one too, right? Hydrants are your biggest thing. And, we've all seen unauthorized trucks filling up at water hydrants. And I see this all the time. This particular example in the picture here, that is a fire department, so it's fairly legit. But there's a lot of places out there that have small construction firms that they go, hell, I'm just going to open up the hydrant and fill my truck up. A, it's stealing water, and B, there's potential for contamination and system damage if not operated correctly. So we should have a means to detect this, unauthorized consumption. A lot of times too, we'll see when we're keeping records, maybe a pressure drop or something, or a flow change in that zone if we're really watching for water theft. Again, like I mentioned, there's new advanced metering infrastructure, and they call that AMI, and it has really good capabilities to monitor customer consumption. It can look at backflow. It can look at, all different things, like even a leak inside your home. This technology is getting better and better as we go, and some of it you can basically log into the meter itself while sitting in your office. The other big one too is the bylaw. There should be bylaws as part of municipalities to make sure that you've got appropriate enforcement mechanisms, right, to address both what we saw here, the water meter tampering, and basically any sort of water theft, and making sure that we're being very, very careful about how people use water. I know a lot of municipalities, what I've seen out there is that they don't allow connections to fire hydrants, just to get away from that. They install water stations or water fill stations that people pay a fee, and they're controlled, and they got a backflow cross connection device on it, so that it's all done to protect our system. but also so that we're not getting any sort of water theft out there. So for the broadest level, efficient water utilities sustain better water resources. They manage energy and they plan for the future water supply infrastructure. And I think that's really what we're looking for here. An example of this is a water utility whose water resources are marginal and adequate at best to meet the demands. It would do well in incorporating a water loss control plan. Because really it's those little municipalities that water's scarce that this really, really hits home. We look at this, it should be also tied to your traditional water restrictions, right? Your water conservation programs out there. This should be a big part of it as well, right? Really showcasing theft and tampering and use of water. And I think, you can get a lot of traction with this. I'll end today with a little case study, Halifax Water. And I had the great fortune to visit this particular site just before COVID hit, and in order to see what they've done here. It's been fantastic. It has been the first water utility in North America to employ that water audit methodology. That's the one that I gave you the link for from the AWWA. It's become the leader in leak management by, they're innovating and employing extensive leak and pressure management controls. So huge. They're doing two really cool things here we'll talk about. They had a real leakage problem, and that was and again, like all sources, they had a source scarcity. Took them, they had to really look at how much water we're using, and they saw, hey, we have some leakage. Now let's look at how we can control that leakage. They did the water audit, and they came up with some measurable outcomes to this. So basically, they've sectored their different areas of their municipality, and they've made district meter areas. And so they've put a large water meter chamber in between all the different areas of the municipality. And so now they know what's leaving the main plant, and they know what's reaching each of the districts, as well as what's actually going in the home. So that's an extra level right there to let them know what's going on. So they can really quickly figure out with their leak detection equipment if there's an issue. And it's simple math. The other big thing they did here, which was really cool, is they employed an advanced pressure management. So basically what was happening is that we all know more pressure means the pipes will leak more. So when they did find the leak, they were able to dial back the pressure a bit in that particular main and until they can get a fix on that. And by lowering that pressure, it really gave a lot of opportunity to have less losses at that particular pipe. Again, look at that. They drove down leakage by 10 million gallons a day. Like, that's huge. And they saved like $600,000 1 year. Imagine the capital upgrades that could be done for $600,000, which is fantastic. So again, they also went that other mile by nobody uses fire hydrants, commercial bulk watering stations, which I totally agree with. I think that's a great way to control water theft. And then with the advanced metering infrastructure coming in, now they're even more advanced when it comes to looking at what's going into people's homes. And this is really a good example of, an older municipality, and they were able to employ these district meters, pressure, reducing stations, as well as putting in AMI metering technology. So to wrap this up, I think all our water utilities and everybody on the call included, I think, you're instrumental in providing health to our communities. Water is huge. You provide safe drinking water on a continuous basis. We can't live without that. The fire department can't do the job without us. We try to do it at a cost that's affordable. We know we're going to lose, whether that's theft or leakage, we're going to lose some. And we can't always recover 100%. But basically, we can start being efficient. These inefficiencies, basically these non-revenue water, it creates a number of problems for us. Nobody wants to waste anything. We don't want to waste power. We don't want to waste water. We don't want any damage too. By doing some extra looking in investigation of pipes and leaks, we can basically figure out a repair before they destroy the neighborhood and blow the streets apart and whatnot. You know, we've lived with losses. We know that they exist, but basically we used to view them as, well, cost of doing business, and invite you guys to think of it one step further. Thank you for your time and listening to me for this last hour on this. I think we're gonna probably open her up for some questions.
Thanks very much, Michael. That was really great. Yeah, I think about it a little bit like we put all this resource into cleaning the water, right? We get the water and we make all this effort to make it safe for us. You don't want it to be, pardon the expression, going down the drain, not getting to the end user after all of that.
If you look at other things that, you know, like it's like leaving your lights on. People have got into the good habit of not wasting energy, or, you know, we don't drive a car to the mall and leave it running. We don't waste
or even your groceries, right? Like you spend your hard-earned money to buy something, you don't want to just throw it in the garbage. So, and water is very precious, even though in Canada we have so much of it, we don't think about that. All right, I have one question. I don't have too many questions so far, so I don't know if Michael's I don't know if Michael answered everybody's questions or not, but I've got one question to start us off with. So Jennifer asks, are there certain types of pipes or joints that are more prone to water loss?
You know, I guess the iron-based stuff, it kind of is. Lots of different factors out there. I mean, it depends on the type of soil, but typically older iron type pipes that were not properly installed or properly protected, or, you know, tend to be the biggest ones I tend to come across. I mean, you see some other types of pipes that, you know, show due to installation error, or, you know, maybe improper compacting or bedding. So all different reasons, and it depends where you are. But old pipe, even the plastic stuff, if it's not put in and it's not maintained, at some point will fail.
Is there a lifetime? Like if I have a small water system and maybe I've inherited, is there a lifetime on certain types of pipes that I should expect to have to do replacements or repairs? I can imagine there are.
I mean, I think goes back again to your particular, you know, community, right? I can have a pipe go in, it's properly bedded, it was installed correctly, it's in a non-corrosive soil environment, and it will last 100+ years. I can have that same pipe go in a corrosive environment. Maybe it was a little bit sloppier or didn't employ any sort of cathodic protection, and it might last, you know, 30 years or 20 years. It really depends on a number of factors, and each are going to be very individual for your municipalities.
Right, but it sounds like there are some, when you go in to do that kind of work, there are some choices you can make then.
Yeah, no, do your homework for your, you know, the type, where that pipe's going. Soil type is huge, how you're going to bed it. You know, especially all this new stuff you folks put in, make sure, you know, it's done correctly, and that you have a standard in your municipality that people are following, so that you're not going back in 20 years replacing something that should be lasting a whole lot more.
Right, so there are steps that you can take if you're in particularly like maybe more corrosive environments to help elongate the life of your pipes.
Yeah, you're gonna look at a material that maybe won't be as corrosive, or you're gonna employ some sort of, cathodic protection or some sort of coating to, make sure that pipe gets the longest life it can.
Thank you. Diana asks, what practice you employ at your current position, water systems? What practice? I'm not entirely sure if I understand that question, Diana. Do you see it in the?
Yeah, no, I think I know what you're
great.
I think we have, two things. We got to make sure what's going in the ground is the right type for wherever it's going, plus the stuff that's in the ground that we start to look at getting out there and doing that leak detection. So employing, getting that baseline really what it comes to. And I think where I'm at today, that's where I really would like to get to. Let's see what I have out there. Let's see if I hear anything or if there's something in the ground that's going to be an issue. And so I got to start somewhere.
Right. Yeah. Good advice. If you take your first sort of survey of your environment, right? Get your baseline numbers. Jennifer again asks, are there risks of increased chemical contamination from lead or manganese in the distribution system with longer retention time?
Yeah, there always is. And that's something to be, depends on the water again. You have water that has, say, a fairly corrosive water. So water with not a lot of calcium carbonate saturation and our low pH will actually start to leach out a lot of the lead and manganese and that kind of stuff if it sits longer. So looking, if that's an issue in your particular municipalities, looking, like Metro Vancouver in the last few years have started adding a pH booster in order to prevent that from happening, right? And that's why you look at the Canadian Drinking Water Guidelines have increased the recommendation for pH for systems in order to make sure that we don't get this leaching from lead and copper and all these other things. Also, too, making sure that we're the distribution system, to be honest, it runs pretty good in most municipalities. The water's moving. It's going to be these very localized dead ends where lead and copper becomes more of an issue is inside larger buildings or inside your home rather than the distribution system itself.
Okay. I think most of the people here are small water system operators. So Michael's asking, are the contractors that offer leak detector work expensive for small water systems? I'm not entirely familiar with small water systems in terms of like the funding versus say municipalities that are larger, right? But I know that funding is a big challenge for small water systems.
Yeah, it is. And I mean, sometimes equipment can be rented. Some of the basic equipment can be fairly inexpensive and, require basic knowledge. So it's something to think about. You don't have to have a full-blown correlator, but maybe even starting with listening to some of your valves with headphones and kind of a listening device. You have to start somewhere, and then looking at if there is potential. If you look at the offset of bringing in somebody to do this, could offset the cost of a major break that could happen in the future that would mean a large amount of restoration work.
Thank you. John Weeb has a question. I think it's kind of interesting. On older water meters, what would the accuracy be? So calibrating your equipment, I would imagine, is an important part of doing these numbers.
Yeah, meters are tough. So meters in the house, like typically they will lose efficiency as they get older and older. And again, depending on the meter, I'm assuming, John, it's the nutating disc style meters in the house. I mean, they got a pretty good life on them. It's percentages, low digit percentages that you'd have an issue with 5%, but it's still 5%. You know, and again, depending on how old these meters are, and you know, the type of water that's gone through them. If you have a water with some grit in it, it's gonna, you know, be worse and worse and worse. Really clean water meters are usually pretty good for in the 20-year mark, and the accuracy would be a very low percentage depending on what they are.
That's great. Any other questions? Does anyone else have questions? Well, we have this great resource here for pick your brain, Michael. Yeah, I mean, so we have a variety. It sounds like a cross-reference of people, but someone here is saying, Michael Dunn is saying he has a water system with 40 users. So they're some of them pretty small systems, right? You can imagine their budgets are really, really tiny to work with. So challenging for sure.
But also easier to find leaks, right? You would be able to do every valve and listen to it, and you know, you can give a lot more time. You know, like you know, a bigger system where you have hundreds and hundreds of valves, really hard to spend that time or have the resources to do it, and to go out there and actually see what's going on. So sometimes the smaller systems, you know, with some education and some, you know, very simple technology. I'll be honest, I've listened to a lot of valves with just a screwdriver on a valve key. I've used that, and it's worked for me for a number of years in the field.
That's kind of a neat trick. Barry asks, how old is old water? And I thought that was an interesting question, because one of the things when I first saw this presentation posted, I thought about water sitting for a long period of time, and like, how long can my water sit in my system before I can't consider it good anymore? Or how does that work?
Well, it varies from, I think the rule of thought is that, you know, 2 days in the line going to the first reservoir. And I'm just saying, if you have a system that has, say, a multiple reservoirs, the estimate is, you know, maybe you got 2 days within the system. You're going to have a day or so in the first reservoir, another day or so in a second reservoir. So when you start to get to the 1 week or the 5 day mark, we're starting to get old. So if I fill the reservoir with, and again, this is all has to do with the amount of residual that's in that water for chlorine, how clean that water is, what the demand on that water is, like if it's, you know, got some organics in it. But typically, I'd say you're gambling after 5 days.
Okay, so 5 days is old water.
That's starting to get old, yeah.
Thanks. Katie asks, what would your advice be to a utility that is starting from scratch? It's a big question.
That's a great question. I mean, for me, you can't manage what you don't know. And I think when you start from scratch, you know, I think going through your system, figure out what you got and what you have to work with. I think, I mean, the asset management and that kind of stuff, and figuring out what's in the ground, you know, or what you think it's in the ground, and you know, because I mean, that's your, especially with smaller systems that didn't have the, you know, don't have really accurate plans. It's in somebody's head. Figuring out what's in the ground, I think, is a big one.
Yeah, and what your ground is. That's one of the things I've been finding interesting is how your ground can affect your pipes and potentially your water.
Yeah.
Yeah. Todd is, I think he's sharing that there's tech available for residual boosting with recirculation pumps. I think that's in reference to the water, right?
Yeah, I mean, those are things, like I said, water without touching it 5 days, but definitely there's mixing that can improve this. There's also, you can have a recirculation pump on your reservoir that will add extra chlorine and extend that life of that water well beyond that 5 day mark. Thanks, Todd.
Another question. I warned you there was going to be a lot of questions. Michael Dunn is asking. Just a second here. If the exact location of the water main is questionable, would a leak detector work picking up a minor amount of leakage?
Let's see. I think if you go to two areas that you know, because usually when you do leak detection, you will go to two known points, and that's typically two of the valves that are on either side of where you think the leak is. The really good thing about leak detection is that sometimes where you think the leak is, it isn't, and you think it's between these two valves, and it's really coming from a pipe one street over. It just happens to be coming up there. So I think leak detection, I mean, it's helped me a number of times on some bigger leaks, just because we would have dug where the water was coming out, and really it was coming from a block over. And it really, yeah, it was a head scratcher at first, but I tell you, it sure, we would have been chasing that, for days trying to figure out where that water was coming from, and, digging up roads and people's backyards and whatnot. So the answer is yeah. I think a leak detection, a leak detector or a correlator or anything would be better than just digging where the water's coming up.
That's a good point. Water is tricky.
Even a small leak, right? It does, a small leak will make noise and it will get picked up.
Right.
Where it gets really ugly and hard to do is the new plastic pipes. It's a lot harder to hear the new PVC pipes. If you have a system that has the ductile iron pipes, it's a lot easier to find leaks on copper and iron type pipes rather than the plastic stuff. It becomes more challenging. It's not impossible, but it's definitely challenging.
Interesting. So is newer technology better at picking up those kind of things? Because there's a variety of newer technology around now.
There is, like, the listening devices are getting better and better, but it still takes an ear to really hear what's going on. Like, technology gets better and better every time, but it still it does take some time.
Yeah, that's interesting to know. Another question from Courtney. Have you ever heard of a small water system recouping from non-revenue users like the fire department, or having a larger catchment than immediate users contribute to cost of upgrading distribution of hydrants for fire suppression purposes?
I think it's rare, to be honest. I think a lot of the time that, maybe there's a bulk amount that's transferred between departments, whether that's maybe the utility kicks in stuff for their maintenance and the fire department kicks in money for, an estimated use. But typically if it's within the same city, I don't often see a recovery for those particular events. I think this is fairly new, and I don't think a lot of people do it.
Yeah, and I mean, the fire department in itself is another public service, right?
It is, and typically, you're sharing one pot of money.
Yeah.
But I think it's important to make sure that that's captured, that there is exactly that. There is going to be
exactly
that is and it has to be recouped, right?
An audit is about just seeing everything, right? Like you said, measuring and getting that baseline.
Exactly. And I mean, it's gonna take time to make sure that that's, it will change. I think, what I do is we know potentially in a wide open hydrant what it would put out. We debrief with the fire department after a major structure fire. I think it's important for municipalities to do after, especially a major fire, to understand potential water that has been used in that suppression.
Rick is asking, so poly, PVC, PEX, Muni are all hard to use sound detection to find leaks. Does it matter if lines are smaller, say 1.5 to 2 inch lines versus the bigger ones?
I think regardless of size, I mean, the velocity goes up as the lines get smaller. So it's a little easier on the smaller stuff, but again, all those poly PVC PEX and Muni, they're all very hard because they don't resonate the sound like a copper or anything like, like copper was used for so many years, and I always love going and doing a leak detection on copper because it's like you can hear it plain as day. If you're really good, you can, I usually go to the nearest valve. Like say in this case here, I'd go to the curb stop, put my key in it, and really because of that brass curb stop with your key, I always put, like I said, my little screwdriver on there and listen to and you can hear it, and that's it's that the resonation from that going through that brass, and that's usually where I can hear it the best.
Okay. I guess the connectors, are they still metallic? Where the pipes connect, the joins?
The valves will be, yeah, the connectors and the valves will be, but typically the, it's harder, right? Yeah. I usually like going back to the valve because I can hear water going through a valve. And if I put my key on that valve, I can usually pick up something coming through that valve, even just listening.
Okay, let's see. Any more questions? I think that's the last one.
Perfect. Thank you very much, everybody.
Thanks, everyone. Thanks for your time today and your expertise. And you've left us with lots to think about and some work to do. So that's great. Just a reminder, we will have another webinar coming up in November. That'll be the last one of the season. So if you haven't registered, please wander over to our website and feel free to register, and we hope to see you then. Thank you for your time, everyone. And in about 24 hours, you'll get your certificates of completion. All right, thank you.